Hello, welcome back to the greenhouse. Today I'm going to be talking about adding some numbers together. So we can take numbers like the fractions, let's take the unit fractions, with a 1, half, a third, a quarter, a fifth, a sixth, a seventh, all up to infinity. Doesn't matter how far we go, well, preferably to infinity, but we'll go up to a seventh for now. And what we're going to do is we're going to take them and we're going to add the first one, subtract the second, add the third, subtract the fourth. So you get 1 minus a half plus a third minus a quarter plus a fifth, and so on. If we take those and carry on adding and subtracting as we go all the way to infinity, we'll eventually arrive at a number called the natural logarithm of 2, which is approximately 0.693147. It goes on forever, well, for a bit. And that's what we would say the sum of those are. But what if we try them in a different order? That sounds absolutely absurd to some people. Making the numbers go in a different order might make a different sum, but I'm telling you it is. So let's imagine a graph. If we have a graph with our x here and our y here, and we're going to say we want to reach a number of 1.5, which we'll denote by here. And what we're going to do is we'll take positive numbers, so that's going to be our 1, a third, a fifth, a seventh. Note that they're the odd fractions, and we'll add them together until we get above 1.5. Once we're above 1.5, we're going to take some negative numbers, a half, a quarter, a sixth, an eighth, and we're going to subtract them. Just enough so you get just below your 1.5. Then we're going to add the odd numbers again. So we're going to add the third, the fifth, the seventh, or how many it takes just to get above 1.5. Okay, we're above 1.5. We're going to do the negatives again. So we'll take the evens and we'll subtract just until we're below the 1.5, and then add and subtract, and it's very obvious to see that eventually we'll have a limit or a sum of 1.5. So we've taken some numbers that we know go to approximately 0.6931, and now we've added them together so that they're 1.5. Surely that's not true, but we've shown it. We can add the numbers together and they'll be 1.5 and 0.63147. But we can take any other number. We can take 1 and we can apply the same thing. Add the odds and subtract the evens, and you get the same thing. We can do that for any number. For any number, you can take this sequence of odds and even reciprocals, and you can make the number just by adding the odds and subtracting the negatives. From here, now we can take it and we can look towards other sequences. Can we do this for other sequences? Yeah, you can take any alternating pattern of numbers, preferably numbers that go to 0 in the limit, as our reciprocals do. So we can take a very large number on the bottom of our reciprocal, and that will go to 0. If you take any sequence that we know that does that, we can apply the same trick. So these aren't special numbers. There are infinitely many of these numbers that you can take and you can make these sequences out of. It's amazing.